everyone. We're going to get kicked off with our session on maintaining transparency across distributed hardware teams. I'm looking forward to this one, A, because of the subject matter, B, because of the presenter. Michael, just a wealth of knowledge of product development, PLM, project management. Actually met him several years ago at IoT conference like this one, where we were on a panel together that he had organized, and we were talking about product development. So he's the founder and CEO of Dura Labs, and they've got a very unique take on PLM and project management across teams. So I'm going to hand it over to him. This will be an informal session. We're going to do a deep dive into the topic, and I see we've got a small audience. I think it'll grow over the course of the session. Patrick, Katie, feel free to ask questions at any point, and I'll hand this over to you, Michael. Thanks for being here with us. And this is all going to be recorded and put online as well for future reference.
Great. Well, thank you, Daniel. I appreciate it. This is something new. I'm actually looking forward to this. This is a new platform that I think has a lot of value and more intimate, I think, than just like a one-way lecture. So thank you for putting this together. I really appreciate it. So as Daniel mentioned, my background, I'm actually a former electrical engineer designing, manufacturing hardware products well over 20 years. IoT, drones, wearables, telecom equipment, you name it, probably built it. And just kind of had a lot of frustrations with how difficult it was to manage the data, CAD files, bill materials, supply chain information amongst my own teams, mechanical engineers, electrical engineers, procurement, and testing, and my suppliers. And got increasingly frustrated with how inefficient the workflows were and the data management tools were. And it was like insult, compounded when I noticed that the software world had an explosion of amazing new tools to help them automate their software development and testing and launching process. And a lot of this stuff wasn't brought into the hardware industry, and I really couldn't figure out why not. There really was no technical or conceptual reason why the hardware industry couldn't adopt a lot of these, what became known as the agile workflow methodologies. And so that was actually a lot of the impetus for launching Dura. Dura's whole premise is to be a very simple, free-flowing data management platform that encourages transparency and simplicity, allowing multiple teams to be able to access information at any point without a lot of friction or overhead. Kind of get into that just a moment. Any questions before I go on with that?
Not here.
All right. So, say again?
No, I was saying, all right, let's go.
So, in today's world, in today's world, speed is a huge competitive advantage for any hardware team. Our world has changed in the past 5-10 years, where software products can be developed and launched in a matter of days to weeks. And as consumers of social media platforms or business software applications, mobile apps, what have you, we've become accustomed to that pace at which products can be launched. And culturally, a lot of consumers expect that of the hardware industry as well. And so the hardware industry is trying to keep up with that demand, but there's a lot of things that are inhibiting us from reaching that same pace. However, one thing that has greatly improved is the flexibility to build out your company, your teams. With the power of the internet, it's been incredibly easy for any subject matter expert or supplier to be able to start their own business and share their services or their wares on the internet. And on the flip side of that, it's incredibly easy for an entrepreneur to put together various suppliers or subject matter experts to build out the resources they need to design and manufacture their products.
And can be done with very little overhead. The old model of a completely vertically integrated company where everything's purchased and managed in-house is no longer necessary. And so a lot of hardware companies can very quickly get up and running and get some product launched to market with very minimal capital investment, which is fantastic. However, it comes with a huge burden and challenge. And that challenge is the inherent massive overhead that has been required to manage all these disparate communication channels and data across the teams. We've inherently created these silos, these pockets of teams and people who may be scattered all over the world and may never have actually even met each other in person. And there isn't a very simple way for them to exchange data or to guarantee that any individual is working off the latest versions of the product data. And this is meant to be an eye chart, but it's an actual, representation of all the different communications and data flows that are representative. And this is just a very small team. So if you kind of dissect it a little bit, this is a team of 2 mechanical engineers, 2 electrical engineers, a manager and some procurement person. And these are all the disparate channels of where data flows, whether it's amongst the different engineering team members, whether it's from engineers to managers, or engineers to the respective suppliers or parts distributors, what have you. All the data, all the CAD files, all the sourcing information, all the bill of materials, all the communication around that information is inherently private or siloed. And this is a problem, right? Transparency is absolutely crucial for communication. Without transparency, without people being able to see what their teammates, their colleagues, or their suppliers have access to, what they're working on, it creates this necessity for explicitly communicating or documenting or annotating what everyone's working on. Yet as humans, we're inherently prone to error, we're inconsistent, what have you, it's prone to miscommunication. And so this compounds the problem. Further, what is unique to the hardware manufacturing industry, it's a very subtle, characteristic, but it's one that's very important to take note of, is that the CAD files that we use, the mechanical CAD, the electrical CAD, are all inherently binary and proprietary formats. And what that means...
I remember trying to reverse engineer the 14 million lines of Altium so we could write some plugins for it. And
how'd that go?
It turned out to be a fool's errand.
Exactly, right? So these application providers, whether intentionally or not, they've created a monopoly on managing their data. And so this is inhibiting transparency. And so without a viewer or a license or what have you, no one else can actually see the contents of these files. On the flip side, the software industry uses source code that are ASCII text, which are native open source formats. There is nothing proprietary. There is no inhibitor preventing someone from seeing what other people are working on. There's dozens, if not hundreds, of text editors, and the format is open source. So there's nothing prohibiting someone from creating their own viewer, their own way of processing the source code to be able to provide additional value. You can't do that in the hardware industry with CAD files without obtaining some license or some permission to be able to access and modify or manipulate the CAD files. And so one of these methods prohibits transparency while the other enables it. And this is a very subtle but very important differentiator. And so while all these tools, and Altium and SolidWorks and the whole ERP packages and traditional PLM packages are very, very powerful products. I'm not knocking their capabilities. Obviously, they've gotten us this far to create some fantastic hardware products in the industry. The problem is that all this overhead that's required to use them, to manage the data going in and out of these tools, are actually costing companies more than they are saving. The manual labor that's required to enter and extract and validate the data going in and out of these tools is extremely high. The time it takes to do these operations have a cost associated with them. They elongate the time it takes to get your product to market, potentially missed opportunity costs, you might miss windows. It adds to the overall overhead and costs and risk associated with developing a hardware product. And this is a problem. And the reason why it's a problem isn't so much just the very forward-facing costs and lead times that it adds to, but it actually prohibits innovation and flexibility. And it actually slows the hardware industry down from achieving a greater level of innovation and creativity that I think we really have the potential to achieve. Because the costs to manage the data is so high, there's a high penalty fee when there's an error. And so when there's a high cost to fail, people don't take risks. And if people don't take risks, they're not innovating. And so this is inherently inhibiting what I feel is the full potential of the hardware industry. And it all starts with promoting transparency and flexibility of the data itself, the CAD files, the bill of materials, and the supply chain. And so this is just, it's a simplified version of what I showed earlier, but I think most people can relate to this. The hardware industry is made up of a handful of disparate teams that each have their own respective contributions to designing and manufacturing a hardware product. And each of these teams has their own technologies and processes and even vernacular for doing their respective tasks. It's kind of like the Tower of Babel. No one's really speaking the same language. These tools, while incredibly powerful, were not designed to talk to each other. They were designed for a more vertically integrated model. And so it creates these data silos, it creates these complex communication processes, it creates this manual overhead that I talked about. And so the time scale to even just set up this infrastructure is weeks to months. This is even before you begin to use it and run a product through a prototyping cycle or a production cycle, and those themselves take weeks to months to run through because of all the overhead and management required. And so the hardware industry needs to change their mental model. They need to flip it. They need to stop hoarding the data and start freeing it and changing the models and the workflows of how we manage the data, how we revision the data, and how we share the data. And so we see it as basically it's a three-step process. And the first one is pretty obvious, right? You need to centralize the information. And that's just get it out of the silos, get it out of the Windows directories, get it out of the Google Drives, get it out of the local PDMs, get it in some cloud-hosted centralized data repository. And companies like GitHub prove that can work with source code, software source code, right? You don't have to host the software, the source of information yourself. You can rely on a third party to manage it for you. And while centralizing the data is important, it's necessary, it's not sufficient. And this is where a lot of other companies have failed, is they just stopped at centralizing information. At the end of the day, it doesn't matter where the data is stored. If there's a lot of cost or friction to getting data in and out of the repository, it doesn't matter if it's centralized. And so that's what the second and third pieces are, is there has to be a very low cost, a low time scale to actually plugging in your respective tools or tasks into this data repository. So there has to be no friction to putting your tools together. And again, I keep pointing to the software industry because I think it's a great model to study and to take from, right? If you look at the software industry, it's been commoditized so much that any junior ranking software developer within an hour can put together their entire tool chain, from their software development IDE to their GitHub repository to some AWS hosting solution, into some CI/CD build server and test framework, right? Within an hour, they can have a complete end-to-end solution because those tools were all designed to work together out of the box. And that's where we need to get to for the hardware industry. We need our tools. We need our CAD applications, our PLM, PDM, or ERP, all these three-letter acronym products. They all need to work out of the box seamlessly, plug and play, frictionless. And that's where the industry needs to go in order for us to be able to move at the pace that we need to, and to reduce the associated costs with managing the data. So why is this possible now, right? In theory, this concept isn't necessarily novel, and the technology has been there for a long time. Well, the reason why it's possible now is because the market's changed, the demand has changed. Who is developing hardware has changed. It used to be pretty traditional where an electrical or mechanical engineer only studied those respective disciplines. But today, it's pretty common and almost expected where any engineer going through a electrical or mechanical engineering program at university is also studying software. And so they're well versed in software development concepts and agile workflows. And it's already permeated into the industry. I mean, just look at this. Like many top software companies, market-leading software companies, are now producing market-leading hardware products. Google, Amazon, Facebook, these are generically, inherently, their DNA is software. Yet they each respectively have market-leading hardware products. And that's proof that hardware is no longer that black sheep. It's now much, much more respected and part of a complete portfolio of the product line of any company. And they recognize that hardware has a place at the table. And so what that means, though, is that the development teams are adopting or coming from cultures that have more software-driven methodologies. And so they're expecting the hardware data management tools to be much similar to how the software data management tools are designed. And so that's why this model is possible today. And that's exactly what we're doing at Dura. So we've built the first data management platform for hardware product companies that has a complete out-of-the-box solution. There is no friction to setting it up. In fact, there's very little configuration required. You immediately have complete transparency across all the different teams, exactly who's doing what. You're guaranteed to always have access to the latest revision of the information. And as you add your different tool sets, it's a plug-and-play experience. There's very little overhead or time involved for getting your system up and running. And so I've been talking kind of high level. So let me bring it down to a more concrete example that I'll presume a lot of people in the audience here can relate to. So this is a real customer of ours. So Scott is a mechanical engineer. On the left is a model of his workflow before he switched to Dura. And this is a pretty common example for a mechanical engineer, electrical engineer, any traditional engineer. Starts off with working on a Windows laptop, right? Predominant CAD software packages are only available for Windows, operating system. Working on a laptop, because of COVID, he's working from home. And so he didn't have access to any kind of file, revisioning system. And so as he was making iterations on his CAD designs, he would just do directory naming or file naming locally on his laptop, right? And his own naming convention. And so when he shared files with his colleagues over email, there was a lot of communication. Which file is the latest? Which one is which? I don't understand your naming convention, right? Separate from that, as he's running through his different design iterations, he would have to manually refer back to the product requirements document, which was managed in some other repository, a Windows drive, had its own revisioning, and confirm that his designs were still adhering to the specifications. So another manual process. Separately, as his designs were maturing, he'd have to go out, to a handful of different suppliers. Most of them these days are, have websites. You can, browse their catalogs or email, if they're, custom services to find, get quotes, what have you. But he's still manually going through half a dozen different suppliers, and each of those conversations about any kind of DFM or changes or pricing or lead time, what have you, is private in his email chain, and other people on his team don't have access to that information or that discourse, and so they may be missing out on important context. And last, once his designs were finally approved, he's literally emailing spreadsheets, zip files, and his CAD files to his contract manufacturer. Again, outside of any kind of revision control system, and outside of the visibility of a lot of the other team members. And so this whole cycle took days to weeks just to do a simple iteration of this design. And then on the right, you have the Dura model. So again, starting off with a very simple concept, which is centralizing the information. So now all the CAD files, all the bill of materials, all the supply chain data has a place, it has a home in the cloud, which anyone can contribute to or have access to see the latest information or roll back to any prior revision for any kind of context. It switched to a cloud-based mechanical CAD package made by Onshape, and so it made the revisioning system automated out of the box. He didn't have to come up with his own manual naming convention revisioning system, which automatically synced with Dura. Likewise, through Dura's integration with a requirements management package called ValidSpace, as his designs were published, Dura would automatically pull the equivalent functional requirements from ValidSpace and confirm that the mechanical designs were still into spec. Mass, volume, any kind of pricing information. And so kind of the analogy being how a software developer has a continuous integration, continuous development server, they can be notified of any tests that fail within minutes. The same thing. Dura, through the integration with ValidSpace and Onshape, can immediately notify the CAD engineer that, hey, you violated a certain mass spec or a certain volume spec. And within minutes, he can be notified and make the respective changes. Likewise, through our integrations with part suppliers like Master or DigiKey or Future, what have you, he can make one inquiry across a dozen different part suppliers at once to find parts that meet his functional specs or pricing or lead time or packaging. And then finally, once the designs were approved, he could deploy the changes through a controlled environment to the MES system, which again, everybody had access to. It wasn't private within an email. And his time scale to run this entire loop was literally minutes. And he can do if any kind of issues came up or any kind of changes that need to be made, is notified by his supplier, he can literally make the changes, run a release, get it approved during his lunch break. And so here's, I think, the takeaway that I want people to take from this presentation. Software development tools were designed to be interoperable and flexible. Traditional hardware data management tools were designed to be powerful yet rigid. And it's time to rethink how we look at our tools. It's time to think of hardware data management tools as a link in a chain, not an isolated lily pad on a pond. Thank you.
Love it. Thank you, Michael. I've got a bunch of questions here, but I'll try and share with the rest of the crowd because I imagine some of them have questions for you as well. I'll just get out.
Please go ahead.
And then, anyone who would like to ask a question for Michael, you can walk on up to the stage, kind of in between him and me, and then ask him. But I'm curious about the handoff between Dura to the manufacturer. Because I see we have a couple contract manufacturers in the audience. We've got Armand from Cento. Lauren from A1 was here for a piece of it. And I'm sure Armand is stoked every time a customer actually gives all of the right data files to be manufactured, right? You probably treat yourself to a nice dinner and wine just never happens. So does Dura help with that handoff and sort of educating or providing barriers to the customer so they have to provide the right stuff to manufacturing?
Yeah, Daniel, that's a great question. Short answer is yes. So just a quick little background. So Dura, was founded by myself and my co-founder Kellen, who also is a very seasoned mechanical engineer, having worked being one of the first mechanical engineers at SpaceX and had his own hardware company after that. The two of us, where I'm going with this is the two of us have been around the block, and we've seen what it takes to design and properly manufacture our hardware products. And so we basically codified our experience and industry best practices into Dura. And so what Dura will do is actually live check your bill of materials, your supply chain information in what's called a bomb scrub, intentionally looking for inconsistencies, erroneous information, missing information, what have you, anything that would give pause to a manufacturer to say, hey, I don't have sufficient information here to build your product, or there's incorrect information, or there's out of stock parts, or what have you, such that when a Duro customer is ready to release their files to a contract manufacturer, it's pretty much guaranteed to be clean and ready to go.
Cool. That's I'm sure that's a huge boon to the folks who use it on both sides of the manufacturing and handoff. So yeah, we have time for one or two questions if anyone would like. You can step up to the stage and ask a question, or you can actually shoot a private message to Michael or myself. Send it some love from the audience.
Sherman, do you have a question?
Yeah, can you hear me?
Yeah, you'll have to repeat Armand's question, Michael, because not everyone can hear it. But yeah, you're good to go, Armand. Michael can hear you.
Okay. Go ahead, Armand.
Can you hear me now?
Yeah.
Yes.
Okay. I don't I have many questions, but then
Sure.
I'll go directly to Michael later. But just to share like a frustration that I felt so identified with what Michael said, because we work together with a software and analytics team, and we try to work as synchronized as possible, and we use agile development tools for that, and it's very hard because the iterations of the software development are much faster, and sometimes like trying to plan.
If you guys all come in closer to the stage, you'll be able to hear Armand better.
Okay.
Carry on.
No, so it's hard because it's hard to synchronize the hardware team and the software team. So
yeah.
I think it's really great what you're doing, or what you're trying to do with Dura. I don't know.
Thank you.
Have a license already.
Thank you. I can repeat that if people couldn't hear. So Herman was saying that he's struggled with the synchronization between the hardware teams and the software teams. They're using different tools and working at different paces. And his words, not mine, he was praising Duro and was excited to use a license so that he could see the merging of the two to simplify his job.
Yeah.
Thank you.
Yeah, I'll use this opportunity to say, Armand also mentioned, like in the topic of a license. So Duro Labs has offered a PDC special for any of the attendees here, where you can buy a discounted any of the Duro Labs licenses from starter up to pro. So check it out. It's over in the gem vault to the left. It will also be sending out an email afterwards. And actually, Armand's company Cento has also offered some manufacturing discounts as well for their contract manufacturing. So I hope all of you take advantage of these good discounts of these great companies. All right, I'll be a little contrarian while we wait for any questions. So, yes, software, the tool chains are better integrated. They're more open. You can set them up faster, but you can also develop it and do iterations in days, as you said at the beginning. Even if you've really got your systems dialed, you're looking at weeks to months to do these full hardware iterations. So maybe it's okay that it takes a month to set up the tool chain, right? Maybe it doesn't need to be set up in a day because that's so much faster than the iteration cycle. And I don't believe what I'm saying, but I got
it. I'll take the bait. There's a little bit of a chicken and egg here, right? It's like there's a lot of pieces in the hardware ecosystem that need to be accelerated. And it's like there's the data flow itself, which is where Duro's really focused on. There's a manufacturing itself, where there's a lot of great suppliers who are finding out ways to more efficiently build PCBAs or, mill, mechanical parts or what have you. But it's like almost like I want to treat it as a race. Like, who can reduce their inherent lead times by several orders of magnitude first, right? And I'll take that challenge. If I can get companies, that's a good day when someone has their tool chain set up within the first day or two of starting a company, and they have designs going out and they're waiting for them to come back, and they're like, you know what, let's spend another design because we have that time, right? Let's try something different. Let's innovate, because a product like Dura or other data management tools are allowing us to very easily spin designs and do what if scenarios without much penalty or cost or the simplicity of rolling back, right? Like how one of the reasons why Git was so successful compared to some of its predecessors like Subversion is because its branching and merging capabilities were so powerful, is that it was very easy to try something and compare it to some other reference point and merge them or separate them, right? And so, whereas Subversion and a couple other predecessors weren't as easy to do that. They're good at revisioning, but not comparison. Again, it's all about lowering the cost to fail. And there's a lot of pieces, of this big pie, absolutely. And I can't wait for the day when, I can overnight, a complex injection molded part, right, and have it designed and on my lab desk the next day. So,
All right, well, touche. I think that was a good rebuttal.
It's a good question, though.
So we're out of time on this one, so we'll need to wrap up. But the plateau stage, we actually have a little bit of time until the next session starts up. So if anyone has any additional questions for Michael, if you were to just sort of step off the microphone and go, maybe
Sure.
off to the right corner of the stage, people can come up and have private conversations with you if they want to learn more about Dura.
Great.
So,
Thank you.
Really appreciate you being here. And, go on.
Yeah, thank you, Daniel. Appreciate it. You and Danny as well. So thanks, guys. Appreciate it.
Check it out.